good afternoon, good evening, good morning, whatever it is when you are listening to this. My name is Cornelius Brothers, and I will be walking you through the basics of dimensional analysis. We're going to call this behind the numbers because we're going to talk about more than just numbers. We're going to talk about the method behind the madness and why we use the numbers that we use, particularly and how we set up our problems using dimensional analysis. I'll go ahead and tell you from the jump, you will not be a resident expert or a master in dimensional analysis at the end of this. What you will be is a little more confident and on the right path to getting to where you want to be. This will take practice, ladies and gentlemen. But by the end of this presentation, you may not be a master, but these are a couple of the things that you should be able to accomplish. First, recognize the purpose of dosage calculation. Why do we need to do this? What is the purpose of it overall? Is it just a bunch of math problems to get through my pharmacology class or through nursing school? Am I ever going to use this in real life? Answer is yes. So we'll talk about some of the purposes. We'll also identify the pertinent information needed uh, and its use in a practical setting. All right. Last but not least, we're going to solve some simple dosage calculation problems using the dimensional analysis method. Yes, we understand that there are millions of ways to solve these problems. Everything from algebra to an abacus, to whatever method you learn in whatever corner of the world you may be listening to this from. But I will say this. There are even multiple ways to do dimensional analysis. Some people use boxes. I'm just going to use some old school fractions, and a couple multiplication signs in between them. Okay, don't be spooked when I say the word fractions. We're simply just going to talk about numerators and denominators. Okay. All right. So just going to talk about some of the simple problems we have. We'll get into a little bit more complex as we go along. But just remember, the key to this will be to take your time to learn the steps, learn the process. And once you do that, I think you'll be okay. All right, so a couple key components, things that we absolutely make sure that we commit to memory. A little bit of background on dimensional analysis. It is known as a unit factor method. Even called stoichiometry in some versions of chemistry. So you'll hear it referred to as a lot of different things. In nursing, typically we call it dimensional analysis. In order to use dimensional analysis, we absolutely first must know our conversions. If you do not learn your conversions, these are going to be incredibly difficult. Even the word impossible says I'm impossible. So I'm not going to say it's impossible to solve these without knowing your conversions, but it's pretty close. And so we don't want to practice our nursing actions using hope and luck, right? We want to make sure that there's some type of science-backed process that we're using to arrive at the conclusions that we need to, because it literally is your lives at stake. If we get a decimal point in the wrong place, we add one too many zeros. That can be the difference between, our patients being alive and unalived. So not being hyperbolic, that is what it is. So when we ask why do we need to do this dosage calculation thing, it's important because we literally are the last line of defense between our patients having good and bad outcomes. Sometimes we need to be that safety net for the healthcare team. I'm not saying that your doctor's going to try to kill your patients, but sometimes it looks like the doctor's trying to kill your patients. Maybe they didn't get enough sleep. Maybe they got 45 patients where you only have 4 to 5 patients. And they're managing all these things, not making excuses for them. This is why you have a license. This is why you need to know dosage calculation so that you can call that doctor at 3 o'clock in the morning and go, "Nah, doc, we can't give that baby that much." I don't know if you confuse this patient with another patient, but we definitely can't administer that much medication to the baby. I did my calculations and that's not going to add up. Before we can do that, we got to know our conversions. You may be thinking, all right, coach, which conversions are we talking about? These right here are a pretty good start. And I just Googled dosage calculation conversion. This is one of the charts that came up. So again, nothing special about the ones that are on here. But if you commit these to memories, you give yourself a fighting chance of getting your questions correct. Okay. I'm going to beg of you, please, please learn your conversions. Okay. Especially using dimensional analysis, there's going to come a point, and I'm going to venture to say about 80% of the questions that you're going to work where you're not going to have all the information that you need in your data set. The data set is simply the problem. If we don't have the information we need, we have to do a little thing that I call BYOD. BYOD means I'm going to bring my own data. Okay. By bringing my own data, all that simply means is I am going to need, yeah, use a conversion. If I don't know the data and the data is not presented to me, I'm going to have to come up with the information on my own. That's what we mean by bringing my own data, simply using a conversion. All right. So please, I beg of you, please on your conversions. And as we go through these, you'll see just how important it is. Once we are have a solid foundation in knowledge, understanding what our conversions are, whether it's milliliters to teaspoons or grams to milligrams, or vice versa, milligrams to grams, micrograms to milligrams. Once we have a solid foundation of those conversions, now we have to understand how do we set this problem up. And dimensional analysis is really, really simple. We're going to start with the end in mind. I often like to have you guys think about going on a trip, and the analogy simply being you can get to a destination without using your GPS, right? But this day and age with traffic and new construction, it's going to work out better for you if you utilize technology. So, in other words, before you back out of your driveway or before you pull out of that parking space, it's probably a good idea to put the address of your destination in that GPS. That GPS is essentially where you want to go, specific instructions on this is where I want to end up. Okay, it's really no different than dimensional analysis because we call that starting with the end in mind. When we do that, we identify our unit of measure, whether it's milliliters per hour, drops per minute, tablets per dose, milligrams, milliliters per day, whatever they're asking us to solve for, that is our destination. That's exactly what we're going to start with. We're always going to start with exactly what the question is asking us for. In other words, we'll start with what we need or start with the end in mind. Then, after we've been nurses for enough time, we'll be able to determine, does this answer even make sense? Right now, when you're working these problems out, you don't necessarily know that, having 15 tablets, for a dose, that's probably not appropriate. You can imagine that my patient probably doesn't want to take 15 tablets. So typically, we're not giving more than 3 tablets per dose. I also know in the real world, if we're trying to give fluids to a 85-year-old patient who's only 85 pounds, and my doc has ordered for her to get fluids, and I'm running those fluids when I do my math at a rate of 750 milliliters per hour, she's not going to tolerate that. So that means if you get, especially on the NCLEX, if you're doing your math and you come up with an answer like that, chances are you probably got a decimal in the wrong spot or something like that. So you always want to make sure your answer makes sense. Give yourself a little bit of grace and give yourself some time, but this will be a skill that you can hone and build over time. We're going to do a real quick practice just to make sure that everybody's on the same page and we can do these conversions. So I'm going to recommend that you commit these to memory old school. Get you some flashcards, put your unit of measure on one side, flip it over, and put the conversion on the other side. That's all that needs to go on that flashcard. Remember, we call it a flashcard for a reason, meaning we can study this information in a flash. I want to put a bunch of information on that. Now it's a note card, and now it's no longer a flashcard. I want my flashcards to be really basic information, things, that I can study in a flash. All right, let's clear that off and head it to the next slide. I'm going to talk about how we start to solve some of these problems. Step one of any trip is you need to know where you're going. You need to have an address. You're going to hear me use this analogy a lot. Identify the stem of the question to find the answers. The unit of measure is exactly what this question is asking us to solve for. It's our destination. It's the address I put in my GPS before I back out of my driveway. Okay. Your book, most textbooks will define the unit of measure is the amount of the physical property being measured, such as drops per minute, tablets per dose, cans per day, etc. So this is asking us, what are you solving for? Do you need to know how many milliliters per hour to set our infusion pump for, or drop per minute, or how many tablets you need to give for this individual dose? Okay, whatever the question is asking us for is exactly the first thing I'm going to write on my paper. So you always start your process with what you need: milliliters per dose, drop per minute, milliliters per hour, etc. What I'm going to highly recommend you guys do as you're learning this process, if you have a practice sheet that's got 10 questions on it, you should read question number one. Go ahead and write number one on your paper. right? Read the entire question. Doc orders this, what I have available is that. How many milliliters per dose are we going to administer, right? That's the first one. I'll draw my line, milliliters on this side, write dose on the bottom because milliliters per is that line, and dose goes on the bottom. This is what I call the setup. Okay, I'm going to take those milliliters and simply move them to the other side. That is my setup. That is how I'm going to start every problem. So don't even worry about the rest of that question. What I would advise you to do now, go to question number 2. Write number 2 on your paper. Draw a line and then read, patient has been ordered for this. Nurse has this available in the medicine cart. How many drops per minute is the nurse going to set the infusion pump? Okay, great. If that's what I'm looking for, drops per minute, I got drops on the top and minutes on the bottom. GTT is the shorthand for drops. I write my equal sign, and I'm simply going to take my drops and carry them over here to the other side. Just the numerator only, the units in the numerator. You notice how I don't have any numbers at all in this problem. I don't need any numbers to do my setup. I would start that way. Then I'll go to question number 3. Number 3, I'm going to be looking for milliliters per hours. My equal sign, because this is an equation. This equal sign right here means whatever is on the left side better show up on the right side. That's what makes this an equation. So I always like to start with something very basic. If I were to ask you guys, what is 3 times 1? And everybody shout at one time. We know that's 3. We're going to do the exact same thing in dimensional analysis. Our equal sign tells us this is the product of all the work on the other side. For dimensional analysis, we're simply going to start with the answer, okay, then our equal sign, and then all of the work is going to be on the other side. That's why you see us starting with milliliters per dose here, and drop per minute with the equal sign here, and milliliters per hour with the equal sign here. All the work is simply going to be found on this other side over here. Trust me, it's going to make better sense as you start to work these. But that's how I recommend. Don't worry about trying to solve them all the way through. Get good at starting the problem. Get good at identifying your address, identifying your unit of measure. What is this question asking me for? And that's how I'm going to start every problem. Okay. So let's look at a question. This is step 1. We're going to identify the stem. The stem is the portion of the nursing question that tells you what are you solving for. So let's identify the stem to find the answer's unit of measure. Okay, question says the nurse is to administer 600 milliliters over 6 hours. The administration set has a drip factor of 30 drops per milliliter. Calculate the drops per minute. We're going to round the answer to the nearest whole number. So in this question, where do you think the stem is? Some people say, well, it's always behind the question mark. Well, not if it's a statement. If they're telling us to do something, it's not going to be a question mark. The unit of measure is the portion of the question that is asking us, what are we solving for? So here, they want us to calculate the drops per minute. In a problem like that, I would simply draw my line here. I'm going to solve for drops on the top and minutes on the bottom. Don't be fooled by this horizontal line. Most computers, they're going to write your fractions as the numerator and then a slash, and then your minutes are going to be on the other side, which is essentially the denominator. So the drops on the top, the minutes are on the bottom. I recommend that you write it in this format as well whenever you're solving, so you can clearly see I have a clear numerator of drops and a clear denominator of minutes. I'm going to finish my setup because I'm going to now carry my drops over to the other side. Simply put my drops on the top, and now I'm ready to solve this problem. Okay, so we're going to get into exactly how to solve this, but before we do that, let's peek behind the curtain a little bit, because it doesn't really do us any good to start to work these problems, but I don't have any idea of what I'm doing or how I'm actually going to solve these, right? So I'm going to calculate the drops per minute. But what am I going to do with this information? What does it mean to calculate the drops per minute? Why do I need to do that? There's a couple reasons. This is a flow rate question, meaning they've given us a volume over a specific amount of time. The volume in this case is going to be drops per minute. There are times where maybe we're not in a hospital or we're in a very austere environment, or the power goes out and we don't have any pumps, or the battery on the pump dies, or pumps malfunction. All those things happen. All those things can happen. Okay, so when that happens, we can't just fold up our shops and go, "Oh, I guess we're not going to administer any nursing care today." No, we can still administer that medication at a prescribed rate. The rate is simply going to be drops per minute. Okay, so when we say drop per minute, sometimes I just need to manually calculate how many drops into my drip chamber per minute. Based on the size of my tubing, I can determine how much medication this patient's going to get. Sometimes we do have a pump that looks something like this. This is the PCA pump, right? So you can see the syringe on the inside here. We can set this pump to make sure that it delivers so many drops per minute. So let's just say our final answer was 30. I'll hit 3, 0, and then enter, right? And that's going to be for drops per minute. And that pump will then administer 30 drops per minute to ensure that my patient receives the ordered dose. Okay. But sometimes they'll tell us that we have a drip factor of 30 drops per milliliter. Don't be confused by drip factor, okay? The drip factor is very, very simple. All the drip factor is telling you, the nurse, is this is the size of the IV tubing that we're using. Not all IV tubing is created equal. Some tubing has very big drops, okay? That would be like 15 drop per milliliter, okay? Or 10 drop per milliliter, right? Some have very small drops, like 60 drop per milliliter, right? That means it takes 60 drops inside of our drip chamber. This would be our drip chamber. It means it would take 60 drops out of this bag, okay? Tiny little drops to equal 1 tiny milliliter. That'd be called micro drip tubing, okay? If we have, in this problem, we have 30 drop per milliliter. So again, those drops are about twice the size of the 60 drops because 30 is half the size of 60. That means it takes 30 drops out of this bag to equal 1 tiny milliliter. The drip factor is telling you what is the size of the tubing that I'm using. That's important because if I'm going to calculate drop per minute, I need to know how big are the drops. Okay, we quantify those in this 30 drop per 1 milliliter. Okay. This is your drip chamber, okay? We squeeze this about halfway. As drops fall into this chamber, we can manually count those to get a drop per minute ratio. Sometimes we'll see this information 0.9% sodium chloride up here at the top, right? You may be thinking, what is that? Am I going to have to, it's already bad enough I'm using fractions. Now I got a percentage in here too. Like, what is this? Okay. The 0.9 sodium chloride is another name for normal saline. Normal saline is the same osmolality concentrated fluid that's currently in your bloodstream. I believe it's about 270 millimeters of mole or something like that. Okay, so that is 270 is about normal for what we have. The 0.9% is simply the name of the solution. You don't need to do anything with that 0.9% sodium chloride. That's just telling you the name of the fluid. I would equate it to if your patient drank 200 milliliters of V8 juice, how would you document that? Well, I'll write 200 milliliters. I'm not going to multiply the 8 in the V8 times the 200. Like, no, that's just the name of the liquid they drank. Same thing with 0.9% sodium chloride. I'm not doing anything with that 0.9%. If this would have said D5W, I'm not going to do anything with those either. That means dextrose 5% in water. So it's sugar water. So sometimes you'll see LR or 0.5% sodium chloride, which would be half normal saline, because if 0.9% is normal, then 0.45 is going to be half normal saline. Okay. So again, those are just names of the fluid. Don't be confused whenever you see that sodium chloride. 0.9% is telling you what the name of the fluid is. Right. And then last but not least, sometimes you'll have a pump that will do milliliters per hour. Whenever we talk flow rate, you may have questions that will simply say, calculate the flow rate. It will be your responsibility as the nurse to calculate the flow rate. We're going to calculate how many milliliters per hour or drops per minute. Key thing to remember, if the question does not give you a drip factor, then it's not possible to calculate how many drop per minute it's going to be. You're solving for milliliters per hour in that instance. Okay, so there is no standard conversion because each of the tubing sizes are different. So if they want me to solve for drop per minute, I have to have a drop factor. We'll pick up the rest of the practice questions in the other video.
And that concludes our broadcast day.